Okay, when I find the equation of a tangent line, now, so we're finding the equation of a line. That's our goal. And for a line, you got to have a point and you got to have a slope. So we know our x value of our point, it's 1. All right, and just to help you out, when we say tangent line, it's like it goes to the curve like this, like it's the I'm not touching you line. It only touches at one point. So it hits it exactly at 1 comma whatever the value of this function is at 1, which we could get by substituting and evaluating f of 1, which would be 1 squared plus 4 times 1. Alright, so first thing I want to find is my slope, which is, it's like my derivative. That's a calculus word for slope. Remember, the definition of a derivative is we use that limit definition as h approaches 0. It's the y2 minus y1 over x2 minus x1 kind of idea that we built. So we evaluate f of x plus h, which is the function's x squared plus 4x. So it's x plus h squared plus 4 times x plus h. That's just all this first part. The second part is just minus f of x. And I'll put my brackets because it's minus the whole thing. That's over h. I can't plug in 0 right here directly into h, so I'm going to have to like kind of do some algebra tricks to kind of cancel out my h. Make sure I distribute that negative. When I square this thing, you see stuff's going to start to cancel out. The x squareds cancel out. The 4x cancels out, and everything on top has an h, which is good news because I want to be able to factor an h out of the top to be able to cancel it with the one on the bottom. Cancel out an h in each part. You're left with still the limit as h approaches 0 of 2x plus h plus 4. And that h at the bottom like kind of cancels out to a 1, you know. And so now it's okay to plug in 0 for h this time because it doesn't make a 0 denominator. In fact, the denominator is just kind of like 1. Our derivative is 2x plus 4. 2x plus 4. Wait, what's x? 1. X is 1 because the problem says evaluate it when x equals 1. So our derivative, our slope, is 2 times 1 plus 4. Just to help you out, let's say they asked us to say it when x equals 2. Well, it would be 2 times 2 plus 4, so the slope would be 8. They said, do it when x equals 3. It would be 2 times 3 plus 4, which would be 6 plus 4. It would be 10, So, but our slope of this line is 6. Because it's at the point 1, so we just find the derivative and plug in the x. Alright, how do I get the point, though? I know the x value of a point. How do I get the y value? Again, remember I said you evaluate it at 1. So instead of x squared plus 4x, it's 1 squared plus 4 times 1. So the point's 1 comma 5. And you can use point slope form, but I don't like point slope form. I just use slope intercept form. And I temporarily plug in place of y, that y value 5. You plug in your slope, because that's your m. You temporarily, in place of x, plug in the 1, and then you solve for your b, which is your y-intercept, and that gives you your equation. So it would be y equals 6x minus 1.